Now what we're going to be talking about is bond enthalpies. All right? And what we're going to look at is we're going to look at broken bonds, and we're going to compare them to the bonds that are formed. All right? And from this, we can determine the enthalpy of the entire reaction. We can determine whether it's exothermic or endothermic, and we can actually quantify it as well too. So the reaction we're going to be looking at is going to be carbon dioxide reacting with 2 moles of ammonia to produce 1 mole of urea and 1 mole of water. I forgot to put my lone pair of electrons on this stuff, but you get the idea. It isn't really going to matter for the actual calculation. Now, what is being broken? Let's look at what's being broken. We have a carbon double bonded oxygen being broken, right? So this carbon's only bonded to 1 oxygen. This carbon's bonded to 2 oxygens. So we're breaking one of these. We can look at the nitrogen. The nitrogen now here is NH2. This is NH3. So we're actually breaking 2 of the nitrogen hydrogens. We can look at what's being formed. What's being formed, we have 2 carbon-nitrogen bonds, as well as 2 OH bonds are being formed because there is no water over here. We can look these numbers up in a table of bond enthalpies, and this is 799 kilojoules per mole. The nitrogen hydrogen one, each one is 391 kilojoules per mole. And so you can sum the 2 of these up and you get 1581 kilojoules per mole. Is the energy required to break it? Now, if we look at what's being formed, I got my cheat sheet here. I don't remember all these numbers. This is twice 293 kilojoules per mole, and this is twice 463 kilojoules per mole. If we sum all these up, this gives us 1512 kilojoules per mole. So 1,512 kilojoules per mole. Now, remember, it's going to be broken minus formed, so we subtract these 2 numbers, and when we subtract these 2 numbers, we come up with 69 kilojoules per mole is what's required for this energy, for this reaction to occur. Since this is positive, this is an endothermic process. All right? Once again, we're going to be looking at a bond enthalpy problem where we have ethanol is going into dimethyl ether. So we're going from ethanol to dimethyl ether. And what we want to do here is, once again, we want to look at what bonds are being broken and what bonds are being formed. So over here, what's being formed or what's being broken is a carbon-carbon bond is being broken. Likewise, an oxygen-hydrogen bond is going to be broken. What's being formed over here? Now on this side we have 1 carbon-oxygen bond. Here we have 2 carbon-oxygen bonds. So we're forming a carbon-oxygen bond. We're also going to be forming a carbon-hydrogen bond as well too. All right. So we're breaking a carbon-carbon bond because we don't have a carbon-carbon bond over there. We're also going to be breaking the oxygen-hydrogen bond because we do not have an oxygen-hydrogen bond over here. What we're forming is, now we've got 2 carbon-oxygen bonds, but we've only got 1 here, so we're only going to be forming 1 carbon-oxygen bond, and we're actually forming a carbon-hydrogen bond. Now in your book, as well as on the internet, there is going to be a table of bond enthalpies, a table of bond enthalpies. And so for the carbon-carbon bond, this is 436 kilojoules per mole. For the OH, that's 463 kilojoules per mole. And if we sum all these up, this is 899 kilojoules per mole. Over here, the carbon oxygen is going to be 358 kilojoules per mole. The carbon hydrogen is 413 kilojoules per mole. If you sum these up, this is 771 kilojoules per mole. Now, oops, it's kind of a bad line there. You take the broken minus the form, and when you do that, you get 128 kilojoules of energy per mole. Now, since this is positive, this is going to be endothermic. That's going to be endothermic. And so that means in order for this transition to occur, there has to be put into it 128 kilojoules per mole of energy for every mole of ethanol you're starting with, and to produce a mole of dimethyl ether. All right? If you have any questions on bond enthalpies, please let me know.